Bonjour! Today we're going to talk about solving systems of equations by using substitution. So we've already talked about graphing to solve, now we're going to substitute, and this is a bit complicated. So don't feel bad if you read through this and you're like, Ms. Stratman, I have no idea what you're talking about. When you see an example, it should make more sense. But as always, feel free to pause at any time and ask me a question. If you're in class, just raise your hand. If you're at home, shoot me an email. I'll be happy to answer your questions. Okay, here's step one. You got two equations. You select one and solve for one variable. So either you're going to get x equals something or y equals something, whichever one's easier to do. So x equals or y equals, that's what we mean by solve for one variable. Then whatever we get, that x equals blah blah blah, or the y equals blah blah blah, substitute that into the other equation. That's step two. Step three, so let's say we have x equals 5y. Take that 5y and solve it, or sorry, substitute it into the other equation. Then solve, because you'll only have one variable at that point. Let's look at the other steps. And yes, this is a bit long. Then whatever value we just got, you're going to substitute it, hence why we're calling it solving by substitution. Substitute it into either of the equations, it doesn't matter which one of the original equations, and then solve for the other variable. The last step is to write the solution. So there are three solutions we might have. If you look back at your notes when we did graphing, you could have two lines that cross at one point. You could have two parallel lines, or you could have two lines that are right on top of each other. So if we look, if you have a point x comma y, and you have intersecting lines, and remember that means it's consistent and independent if they cross. Okay, if you get null set, you're going to get something that's totally false. Like if you get the answer is 4 equals 9, 4 never equals 9. That's crazy. That means you have parallel lines. Remember, when you have parallel lines, we say that's inconsistent. And the last possible solution you could have an equation for a line. You get a point, but you get an equation for a line. And that's when you get something that's always true, like 5 equals 5. Yeah, 5 always equals 5, duh. That's when you have the same line. And remember, that's an infinite solution. So remember Buzz Lightyear, to infinity and beyond. Are y'all too young for that? I hope you're not. Anyways, infinite solution. And to date myself, I saw the original Toy Story when it came out in theaters. It was amazing. So that's an infinite solution, and remember we call that consistent and dependent. All right, let's jump into an example. Okay, here's our example. I'm going to call this equation A, negative 2x plus y equals negative 2. And equation B is 3x minus y equals 4. Okay, we said step one is to select one equation and solve for one variable. So, I'm going to take equation A, and I'm going to solve for y. Since y doesn't have a coefficient, it makes it pretty easy. So let's take equation A, which is negative 2x plus y equals negative 2. I need to solve for y. That means get y by itself. Well, notice we have negative 2x plus y, so we need to add 2x to both sides. Both sides of the equation, I should say. Okay, on the left, negative 2x plus 2x, that's 0. We just have y. Fantastic, that was our goal. Now be careful. Remember, this one has an x. That negative 2 does not. Do not combine them, please. So we just end up on the right with just 2x minus 2. Fabulous. That's step one. We solved for a variable. We just have y equals. Okay, now we want to go into step 2. Okay, here's step 2. We're going to take just this part, this y equals. We're going to substitute it into the other equation. So here's our other equation. Instead of writing 3x minus y, instead of y, we're going to write 2x minus 2, since we just said y equals 2x minus 2. So this is what we're doing. Here's our other equation, not the one we just used, is 3x minus, but instead of y, we're going to substitute in this, since this is equal to y. So minus 2x minus 2. And that still equals 4. Okay, now we got to do step 3. Notice how we only have x's now, no y's. So we need to solve for x. So if you look up, if you're in our classroom, you can look at the poster. First step for solving, deal with the parentheses. So remember, that negative is really a -1. That's a -1 hiding out right there, -1. So we need to distribute that -1. So 3x is still 3x. -1 times 2x is -2x. -1 times -2, that makes it +2. And that still equals 4. Okay, we've distributed. Now we need to combine like terms that are on the same side of the equation. Well, this has an x, this has an x. And then these two are on different sides of the equation, so we don't mess with them. So 3x minus 2x, that gives me just 1x, so I can just write that as x. And then bring down everything else. X plus 2 equals 4. Okay, next step for solving, add or subtract. Well, we got x plus 2, so that means we need to subtract 2 from both sides of the equation. That x comes down. 2 minus 2, that's 0. So x equals 4 minus 2, that is 2. So hey, look, we got x equals 2. That's fabulous. So we solved for the variable. We got x equals 2. Okay, step 4 says take the value that we just found, x equals 2, and substitute it into one of the original equations. So here's step 4. Now I'm going to put this x equals 2, I'm going to put it into equation A. You can put it into equation A or B, it really doesn't matter. I'm just choosing equation A. So reminder, I'm taking equation A. So that's -2. And then instead of x, we just found out x is 2. We're going to put in that too. So -2x plus y equals -2. So again, that's just the original equation A, but instead of x, we just found out x is 2. So I plugged it in. All right, now we need to solve. Just like before, first step of solving, deal with those parentheses. So -2 times 2 is -4. Everything else gets dropped down, plus y equals -2. All right, next step of solving, we don't have any like terms that are on the same side, so we need to see what we can add or subtract. Well, we want to get y by itself. We have -4 plus y. That means to get rid of that -4, we need to add 4 to both sides. All right, -4 plus 4, that's 0. We just have y equals -2 plus 4, y equals 2. All right, well, hey, notice we got an exact point. We got x equals 2, y equals 2. So that means, looking back at our original problem, so we're trying to find the solution to this system of equations. Where do these two lines intersect? And the answer is these two lines intersect, or the solution to this system of equations is at 2, 2. There's our answer, yay! I'm going to be crazy and do a crazy line around it. That's our final answer. So those two lines intersect exactly once at 2, 2. All right, you have some practice to do. Get to it.